Alright, time to clean up this mess. When we're cleaning a data set, there are two things that we can do. We can delete columns and we can add columns. When deleting columns, remember that it's a lot like burning a bridge. If it's completely useless and getting in the way, feel free to do so, but if you feel like you can use that bridge in the future, then don't delete it. This is really a judgment call for you to decide on. We can also add new columns to our dataset full of useful information. A very important thing to remember here is that we cannot invent data, only build off of it. If we decide to create numbers of our own, then the integrity of our information is lost, and our visualization at best can become useless, and at worst can give us business suggestions that are just wrong. Derive information, don't develop it. So as an example, you can create a sum of two numbers, but don't just fill it in with random numbers that you feel like adding. That ends up hurting you more than it ends up helping you. So looking over here, this looks good. We can see that we have a very nicely formatted, clean new data set that we can use, and everything looks nice and clean. Alright, so to reiterate why we want to do data cleaning again, it's that when we are going through our information, trying to create a visualization that will easily allow us to pinpoint where we want to sell our product and market, we want to make sure that our data set is as slim and trim as possible, and it also has all the necessary information that we need to make sure that we're ready to make a visualization quickly and easily. So let's jump into Tableau again. And over here we can see we have a bunch of different columns that we've worked with. These are all in the Excel file. And say that we have our entry dates over here, but we don't want the entire date. Maybe we want to group everything just by year. So all we have to do is go over here to this drop-down arrow, go over here to custom split, and split using a certain separator. So separators are just a character that the computer is going to cut off at, and we're going to split off from the last. So you can do it from the first, last, or continually split everything. And you can choose how many columns that you want to do. So we can click OK, and all of a sudden, there you go. We have a nice column including only the years at this point. We can double click on the title to change the name, so we're just going to change this to years. And as a last note, you can only do the split function when you see this little ABC. This means that it's a string, and strings are useful because they're treated as lines of just letters or numbers. Essentially, they lose their ability to do math and lets you do this operation of splitting the string wherever you want. Once more, be careful. I'm just going to offer a word of warning that if you decide to go and change everything to strings and start splitting them wherever you want, you will not be able to do math. So for example, I wouldn't be able to add these two numbers if they were strings that I wanted to split. So just keep that in mind when we're working. Let's head back to the presentation and start discussing the actual process of creating a full-on visualization now that we have a clean data set. Okay, it's time to start visualizing. Remember, we want what we create to be killer, not filler. We should be using our visualizations to help guide ourselves and our viewers along a problem-solving process, not to distract them. To do this, we can make use of visual cues. Visual cues are graphical tools that we can use to bake more information into our final viz. These little hints lead the viewer through a story that ends with the conclusion that we've made ourselves. Very quickly, you can see some commonly used visual cues on the right, such as length, angle, color, volume, and area. We've already seen how effective the color cue can be when used properly with warming stripes, and from this point on, we'll be introducing new visual cues with each hands-on portion of the workshop. While visual cues can be used to bake information in, it's good to know that you can also use them to shift focus as well. In this case, you can think of visual cues as a highlighter, making certain elements of your data pop when many are present. Let's try doing this right now to inform the decision of where to plant our crops. Okay, let's go ahead and create our first visualization. So, when we're doing this, we're going to try and uncover hidden patterns within our data, and from there try and make sound business decisions to try and figure out where we want to plant our crop. Now, to me, just spitballing off the top of my head, I'm thinking that if I want to find a good location to sell my drought-resistant crop, I'm probably going to want to look for a location that's very hot, because if it's hotter, there's probably less water, which means that there's probably a higher chance for a drought. So what I'm going to do is I'm going to first hop over to Tableau. Whoops. Here we are. And in Tableau, I'm going to go ahead and start by tapping over here on Sheet 1. So this is our sheet view. It's very useful. This is where all the magic happens in Tableau. So idea. Let's go back over here to country. We're going to drag and drop them over here in the rows section. So now I have every single country. I want to see how their temperature is changing over time. So what I'm going to do is I'm going to go over here to our measures and go over to study midyear, drag it up here in the top, and then all of a sudden I have this nice looking graph. Now, this isn't exactly what I want, mostly because Tableau automatically adds numbers together into a sum. So what we're doing is we're looking at actually the sum of all the years that it's holding, which isn't useful at all. So we're going to change this from a sum to a dimension. And we're going to change this study midyear one more time from a continuous variable to a discrete variable. We're going to talk about what this means later. Okay, so now I have my nice big table over here. It has all my countries and it has all the years that I have data in. But right now, all I see are ABCs. I want to see what the average temperature for every single year is. So what I'm going to do is I'm going to go over here. We have, luckily, the mean annual temperature. And all I have to do is drop this pill into text. And there you go. I have my numbers. But 127.9. That doesn't seem right. I don't think that anywhere in the world is going to be reaching 298.7 degrees Celsius. And again, if we look over here, it's because Tableau automatically puts it to a sum. We're going to change that from a sum to an average because we want to average out our temperature for every single year. And all of a sudden, we have all of our temperatures, we have our year, and we have our countries. Now, if I went to a investor and they said, why did you choose to put a country there? And I show them this, they're probably going to think I'm crazy. So what we can do is we can start highlighting information so that we start to get a better idea of where we want to actually look at hotter locations on the map. So what we're going to do is we're going to pick up our pill for mean annual temperature again and drag and drop it onto color this time. It's going to start in sum. So I'm going to change it from sum to average like we talked about. And I'm going to do something interesting. I'm going to go up here and instead of keeping it on T, I'm going to change it to a square. And then that fills it in nice, just like this. So we have our colors, but 29.5 degrees is dark blue. And we can see that over here is because our scale with our temperature, orange is cold and blue is hot. Now, like we looked at when we were looking at the warming stripes example, we saw that typically we think of blue as being cold and red as being hot. This isn't very intuitive. So why don't we change that right now? All we have to do is click on this small drop-down arrow, go to Edit Colors. From Edit Colors, we can click on Reverse. And then all of a sudden, we have red being hot and blue being cold. Let's click OK there. And there you go. We now have all of our items over here. Now, if you can't see any of your numbers anymore, that's okay. All you have to do is just click on this button up here. This will hide and show our text. And there you go. If you don't have it, now you do. Lastly, you may be wondering how I got these nice boxes. All you have to do is you have to click on color, and then you can change your borders. And then there you go. You got those two. Now, I want to see which is the hottest country here. But I'm having a little bit of an interesting problem. Because everything above 0 degrees is hot and is getting into the red zone, I should say. And most countries here have measurements in above 0 degrees Celsius. We're not going to be getting a real contrast between the countries that are colder and hotter with regards to one another. We want to look at the average heat of everything here. So all we have to do is to kind of get like a better feel for the data set itself rather than the absolute freezing point of water. All we have to do is go over here to Advanced, change our center to the middle of this spectrum, which I'll tell you right now is about 10 degrees. Click OK. And there you go. Now we can see which countries are colder and which countries are hotter in relation to one another because we're sitting at the middle. So looking over here, we can see that Brazil is very hot. We can see as Canada is fairly cooler. And going over here, we see the US is kind of a mixed bag because it's such a big country. Now, that brings me to another interesting point. Some of these countries are so big and they'll have measurements from all over the place. So maybe this method of looking at temperatures strictly in a spreadsheet aren't that helpful. Maybe you'll have to look at other things. So say for example, Brazil is very hot, but we know that Brazil is in the middle of a rainforest. So even though it's very hot, it's probably getting a lot of precipitation. So yeah, I personally think that although we did start moving, we are starting to move in a good direction for trying to figure out where we want to go. I think that this visualization hasn't been entirely helpful. Let's jump back to the presentation right now and see what else we can give a shot at to try and figure out where we want to plant our items. The spreadsheet viz that we built turned out not to offer a deep enough understanding to pinpoint drought-prone locations. We'll have to take a more thorough approach to get answers, and I think a few graphs will fit the bill. Graphs are incredibly useful tools when trying to find hidden details of a problem, but before we build one, we need to understand when to use which graphs. There are two types of data that we'll be covering right now, and one a little bit later. The type you have will determine the types of graphs that you can use. The first is called numerical data, and deals with numbers. The other is called categorical data, and deals with things that fall into categories, like colors or movie genres. Categorical data can also be broken down into ordinal and non-ordinal data. Ordinal categorical data is any set of categories that you can put into order. Think of months, like to dislike on a sliding scale, or movie franchises if you feel like starting a civil war. Non-ordinal data is any set of categories that cannot be ordered. For example, you can't give definitive rankings to colors, movie genres, or car makes. To make sure that you have a solid grasp on this information, here's a quiz. In the first blank, you put either numerical or categorical, and in the second blank, you put the subcategory of whichever one you chose. Pause the video right now, give it a shot, and then unpause when you're ready to hear the answers. Okay, in a sample of 1,000 Canadians, each is classified as either a Marvel or DC fan. This is categorical because it's either Marvel or DC, and non-ordinal because you can't order these two franchises. 2. A biologist measures the height of tomato plants. This is numerical because you're ending up with a number, and it's continuous because you can always go smaller and smaller when you're measuring something like height. If you have 1 meter, you can go down to 0.5 meters, you can go down to 0.25 meters, and so on. Now that we know the different types of data, we're free to pick whatever graph best fits the situation. Included in this workshop is a cheat sheet that gives you a table full of what types of graphs are best for what combinations of data. The best part is that Tableau actually already does this for you. By clicking on Show Me in the top right-hand corner, the software will automatically pick what type of graph is best based on the data that you've dragged into the sheet section. Remember back to our last viz. We determined that looking at temperature alone wasn't enough to determine if an area was going through droughts. We need to look at precipitation rates as well. So let's go ahead and take a look at our data and see what we have to work with. So, let's see. We're back over here in the data source. And mean annual temperature and mean annual precipitation. Both of these are numerical data values. And if we go to the cheat sheet that we give you guys, we can see over here that with numerical axis 1 and numerical axis 2, we're going to want to use a scatter plot. So we're going to go ahead and now plot these two values, precipitation and temperature, and see when we have points that are outside the normal range of precipitation for that area's heat. When that happens, if there's too little for that area's heat, then we can have a pretty good idea that that area is suffering from a drought. So why don't we go ahead and do that? So first things first, at the bottom we're going to have to open up a new sheet. So there are 3 buttons over here. We're going to want to click this one, and you'll see a little dialog box open up over there that says New Worksheet. So let's click there. We're going to want to compare, as we said before, mean annual temperature and mean annual precipitation. So let's go ahead and drag these two. We'll drop this one on up top. So that's precipitation. Actually, let's go ahead and put precipitation in rows. And let's put temperature in columns. We're only getting a single dot right now, but remember that's because Tableau gives everything starting off as a sum. We're going to want to make these dimensions because we want to look at each individual point. And there you go. We have a nice looking graph, or scatter plot rather. Now, once again, this is functional if you know what you're looking for, but I feel that we can bring out a little bit more information by playing around with some visual cues. So let's go ahead and do that. First things first, I am going to change from automatic to circle because I like the filled in dots. Whether or not you want to do that is up to you. There is something else that we can do here. Something that we can use to check whether or not an area is receiving proper amounts of expected rain. So we know that we can group climates together. So say you expect a desert to get less rain than a rainforest. These climates or ecosystems are also called biomes. Now we have, luckily, a dimension that lists what biome each of these points are taken from. So we can put this in as a visual cue, and then looking at it through the lens of this new visual cue that we've put in, we can try and get a better feel of whether or not this place is receiving too little rain or too much rain. If it's receiving too little, then we have a good idea that that area is suffering from a drought. So I'm going to go ahead and pick up biome, drop it down into color, and then boom, all of a sudden we have this nice little legend pop up over here, and now we can get a better idea of where everything is supposed to sit. Now you may notice immediately some things that are very, very low with regards to amount of precipitation, but I can't offhand tell you where exactly it is. For example, this point over here, well, I want to know where this is because this seems, with comparison to all the other red points, to be very, very low. Same thing over here. But I can't tell where that is. And from this point, I think it's time to introduce a new visual cue that will let us explore exactly where those points are. So let's head back to the presentation. And let's go. The first thing that we should do is establish a more concrete way of determining whether a point is lower than we expect it to be. This is where the trend line comes in. It's a line that highlights overall patterns in our data. There are different ways we can use trend lines, with each of them highlighting different things, but today we'll be focusing on what many of you will know as a line of best fit. A line of best fit is a line that attempts to capture the effect that one variable has on another. Does decreased heat mean more rain? A trend line will give us a rough answer.